Son, where'd you find this?
That's how you know somebody doesn't respect you. That's how you know somebody doesn't respect you. They listen to reply, not to be understood. They cut you off. They minimize what actually matters to you. They laugh at your boundaries, and then they call you sensitive when you try to hold the line. They show up late, they cancel last minute, forget the things you've told them, because in their world, your time, your energy, even your voice aren't a priority. They're just an option. You see, there are two kinds of people. Those who adjust when they realize they've actually hurt you, and those who expect you to adjust so they don't have to change. You don't need to be disrespected loudly to be disrespected deeply. Sometimes you'll see it. It's just in their tone, in their patterns, in the silence after you're known. Respect isn't what they say when they're watching. It's how they act when they think you'll tolerate it.
His own attitude towards the possibilities of peace, towards the Soviet Union, towards the course of the Cold War.
And so it was a way of making me feel that they were a part of it.
You see it on the screen. If the government had to change the school in the grid, they have to shut it down. We got state troopers out there. They got planes flown. They got the strange machine.
What's good, people? Peace and blessings, glory, praise, and honor to the Most High. Happy Wednesday. I hope all is well. We are halfway through the week. The weekend is upon us. And I hope you got the right mindset going into it. I know the week can be stressful, especially once you get to Wednesday. But you here, that's all we should be grateful for, the present. Shout out to my poets, writers, content creators, and all of the good stuff in between. You know, I'm gonna give my flowers out where they are due. You know what time it is, you know what segment this is. Sydney is in the building. Honored to have her. I'm going to bring her up. Do me a solid like, share, repost. Let the people know we are on, especially if this is something of interest to you, especially. With that being said, give her a warm welcome. I'm going to turn it over to her, let her do her thing. Sit back, relax, grab you something to drink, snack on, and let's have a good show.
Hello. I don't know if you can hear me. I can't see myself, but oh, there I am. Okay. Hello, everyone. My name is Sydney, and today's topic is about 3D printed houses. I really wanted to talk about this because it's becoming talked about. It's a idea that is being considered more and more, especially given our housing crisis, both here and around the world. We have way more people than we have homes for, and this apparent building shortage, I won't get into it, but there are some theories that we don't actually have a building shortage. It's actually the control of the market. But again, I won't get into that right now. Because there is a shortage of available housing, the cost of living is also increased, which increases the value of the homes and makes it harder for people to actually afford homes. In most large cities, most entry-level job people, workers, most families are not actually able to afford homes. Back in the 80s, I believe, I think like 65% of families just out of college were able to afford a home. Now that number is about 15%. And in cities, that number's lower. So it is particularly relevant right now because there's a lot of companies, a lot of areas that are starting to explore different methods of producing homes. And with the rise of 3D printing in general, people have applied this concept to creating homes. They've created large machines that produce it's basically the same process where if you look up videos, it like makes squiggles in the form of a house, and they basically 3D print the homes out of concrete. I think it's also a mixture. There could also be additional components added into it, but it's according to a company talking about 3D houses, 3D printed houses, it's a custom concrete or mortar mix. So it could depend on who you are buying the home from, but generally these houses are made out of concrete. So currently it's still in the early phases. Has not been a lot of testing on these homes. There haven't been long-term experiences with them, so we don't know very much about how well it can last. And already we're starting to see some issues arise with 3D printed homes. I've watched quite a number of videos talking about people who bought them or who are examining ones that have already been built. And sometimes within a year, or sometimes even less, there are already cracks that are forming in the walls. And so there's already structural issues with the buildings that they're creating, which obviously that creates a huge problem if you live in areas where you get a lot of snow or fluctuations between heat and cold. The process of heat and extreme cold on stones will force them to break apart over time. Same thing can happen to pipes and whatnot. And so if you have these cracks developing, it already puts your structure at risk and is more susceptible to the fluctuations that come with temperature changes. So you could possibly start seeing leakage into your home, crumbling of the structure, or potentially other issues, mold intrusion, and an instability in particular weather conditions. Another one which has not been tested really at all is the seismic resilience of these homes. In California, or in seismically active areas, which California is definitely one of those, brick and mortar is not safe to use because mortar basically turns to dust at the same frequency that earthquakes resonate at. And so if anyone remembers or has seen pictures of the San Francisco earthquake in 1906, that really made scientists aware of how dangerous stone houses are in seismically active areas, because once you have a seismic event, earthquake, impact that area, if you have homes that are made out of stone, basically it'll just fall apart around you. The walls will collapse in. A lot of people in the San Francisco earthquake were killed just from the walls collapsing in on them, allowing the roof to also collapse onto them. So being in a stone house during an earthquake is quite potentially very dangerous. And so, granted, this isn't pieces of stone being held together by mortar. This is all one cohesive block, if you will, of concrete and mortar. But it still has that risk. And we haven't had these homes around long enough to see what would actually happen during an earthquake. And this could have just been my own lack of research, but in that particular direction. But I don't think there's been any seismic testing to examine how exactly an earthquake would affect these types of structures. In laboratories, building laboratories, they do test what happens to structures in earthquakes. This is why Japan has some of the most earthquake resilient buildings in the country, or in the world, really, because they have done tremendous amounts of engineering testing. They make really scaled down models of buildings to see how they respond to particular types and intensities of shaking. And so they've basically been able to make homes, or even skyscrapers, buildings that move with the earthquakes, that have essentially giant, pads, if you will, underneath the house that basically absorb all of the shaking. And so instead of the house absorbing all of the movement, it moves on top of a table instead. And so the table absorbs most of that shaking instead. And so the building is able to be intact. They've also made some of the structures more flexible so they can essentially sway back and forth in the earthquake without actually collapsing. And because of how new this is, I doubt we have done any rigorous testing with engineering minds to kind of see how these structures are able to fare. Additionally, the resilience of that structure will also depend on the shape of the building as well. Buildings that have four walls are more likely to face a collapse than round buildings, if I remember correctly, because you have the joints and the earthquakes are able to break those apart. And once you have kind of separated them at the corners, it's easier for the walls to come down. So this one's just my speculation. I imagine that the round houses are probably going to be better off than the square versions. But again, this kind of testing has not been done yet. We've only really had ground testing. And there has not been a significant earthquake in the past 5 years to a decade, even though we really haven't been doing this for a decade at all. Only, I'd say maybe like 5 years or less. We don't have any data or anything in that area to show whether or not they're actually going to be safe for people that live in them. Of course, there are benefits to 3D printed homes. One of the biggest aspects that make it a desirable method to build homes, particularly with this housing crisis, is the fact that you can build these homes, print these homes in a very short period of time. You can sometimes, depending on how big the home is, you can print the shell within 24 to 48 hours, but you do still have to wait as well. I'm sorry, I have the hiccups. But the full completion takes weeks. It does take a while for concrete to completely solidify, and that also has a lot to do with the environment that this home is being placed. So even though it still goes up significantly faster than homes nowadays, but it still can take a while to build these homes. If I remember correctly, small, like the tiny homes that people are getting, those do take less time to be created than the 3D printed homes, just because of the curing time and whatnot. But again, with all of the housing regulations, it's not very easy nowadays to find a place to put your tiny home. I do wonder how zoning regulations are going to affect the accessibility to 3D printed homes as well, because the housing industry historically has shown a disdain for anything other than normal modern homes, just because they don't want to have to deal with the repercussions if there's something wrong with the house. And there's a lot of enforcement about how big your home has to be, what it has to be made out of, what it has to contain in it. So even if we do perfect 3D printed homes, there still could be a lot of issues with zoning regulations and whether cities allow them to be printed. Another benefit of 3D printed homes is that you're saving a lot of money on the labor that it takes, because you don't need a bunch of different people to do a bunch of different tasks. You're really working with only one material, so you don't need the carpenter, wood person. You don't need all the other, it it takes a lot of people. I don't know the names of all the types of construction people, but there's a lot of different expertises that are required to build a wood frame house, a brick and mortar house, pouring foundation, all that fun stuff. So because it really uses a printer to do the bulk of the work, you really would only need like the engineers that are involved in producing the design, monitoring the production, possibly people to create and work with the material that they're printing with, and any other features that house contains. It can also lower the cost of the house because you're not using as many materials. Nowadays, wood has become significantly more expensive because high quality wood is not very accessible anymore. The reason we had so many wooden houses prior to the 1950s and before was because we used to have massive groves of trees that were huge. Just look at the forests along the West Coast and the types or the sizes of those trunks. You could fit. There was one tree they cut down that they were able to have a party with like over 20 people on the trunk of that tree, the stump, because it was such a large platform. They could be 15, 20 feet across in some cases. And when you have trees that are that large, you end up having solid boards that are that thick. And that wood is going to be far more thick and stable compared to the type of plywood that we have today. Additionally, because the trees were less stressed back then, the wood was a harder wood, and so it was more resilient to pests, to temperature changes, and to like temperature in general. Like it was a really good insulator. Compared to now, a lot of trees are farmed where we grow them in cycles, kind of in the same way that we grow crops. But these trees are only 5, 10, 15 years old. And when you have trees that are that young, the wood is going to be a lot softer, have more cellulose in it, which makes it more spongy. So you're more likely to have issues with water intrusion, mold, fungus, beetles, stuff like that, eating at your home, termites. And so the wood quality that we have nowadays is not the same as it was in the past. And so it high quality wood is becoming much, much more expensive than it was in the past. It's not readily available now. A lot of old growth tree regions are completely inaccessible for protection status. But that limit to production decreases the access to high quality building materials and thus increases the cost of quality building materials. So using just concrete can help lower the costs and in turn make the house more accessible to lower income buyers. Another benefit is they in some ways can be more eco-friendly. The systems can use recycled materials and are a little bit more lower carbon than the production for traditional homes. But it does depend on the mix type. Concrete has its own issues with environmental impacts. Not only the acquisition process, but also the concrete itself. The concrete itself is from, let me check. I think it comes from, yeah, that's what I thought. So the cement industry is one of the two largest producers of carbon dioxide. The production itself emits a large amount of toxic substances into the air, and it can actually cause respiratory problems, especially for people that are producing it. It depends on who you're going to get the concrete, but cement can be a wide variety of mixes. Most commonly, it'll include calcium, silicon, aluminum, iron, and this, we've used this for a very long time. You probably would be familiar. Romans used concrete. Mayans and ancient Egyptians used concrete, but they did use different compositions. Some of them used limestone, some of them used volcanic stone. And today, modern concrete relies on a mixture called Portland cement. But the creation of the cement is incredibly carbon intensive. Not only do you have to calcinate the limestone and heat the cement, but the cement itself, even when it's like hardened and done curing and everything like that, it still actually releases carbon emissions into the environment just from the rock itself as it breaks down. It releases most of the CO2 from a chemical reaction within the cement as it's being cured, but it produces a tremendous amount of pollution. Right now, as of 2020, so tiny bit outdated, but as of 2024, the construction sector of the industry, which includes concrete, iron, and steel, generates 27% of the world's carbon emissions. And concrete itself is responsible for 7% of that amount. So it's a quite significant proportion if you kind of look at the math of it, especially if we move into a world where we're increasing the production of concrete-based buildings. Additionally, concrete as a stone is going to heat up the local environment. If anyone has ever been on an unshaded park with concrete ground, you'll notice a significant temperature difference than if you're like on the grass. So in a way, the use of cement can add to the heat island effect, where cities tend to be hotter than the surrounding natural areas because all of the concrete and asphalt makes the ambient temperature hotter, because the heat is absorbing, the heat from the stone. Let me start over. As the sun shines on the cement and asphalt, it heats up and then it re-releases that heat into the environment. I'm sure we've all walked on a hot sidewalk and have seen the heat waves coming up off the ground. That contributes to the heat of a city. And so a city can be significantly hotter than the surrounding areas by as much as like 10 to 20 degrees. You can see this most notably in places like California and Arizona that are desert regions that get a significant amount of sun. But it's a very common occurrence with very large cities. It's actually bad enough that a lot of places are starting to paint their roads and sidewalks white. That way they can at least reflect a lot of the sunlight instead of absorbing it into the ground material. So if you do live in a hot area and you are going to get a 3D printed house, you probably want to paint it white. It's actually why you see a lot of like stone whitewashed homes. There are other reasons for it, but it can reduce the inside temperature of the home. Another issue, which is one that we're already facing with the rise of AI, is the water use. Not only does cement require water to create, you have to mix water in with the cement mixture, which comes in as a powder, which is also why it's so dangerous to breathe in, because you're basically breathing in tiny particles of rock, which is not good. If you imagine having a coating of cement in your lungs, that is basically what happens to people that are breathing it in, particularly those that are working with it. Anyway, it uses a tremendous amount of water, and we already are using up our water resources faster than it can be replenished. And they currently, as of right now, 9% of all water withdrawals is used for the concrete industry. So not only do they produce 7% of the emissions, they also are responsible for 9% of water reductions. And if we increase the production of concrete for these 3D homes, we're going to see another waste of water material, of water availability. And I mean, with AI, we are already seeing people in communities where the AI facilities are located run out of water. They don't have water coming out of the taps, or the water that they do have coming out of the taps are extremely contaminated and unhealthy. It's happening in cities all over. Not to mention, we already have been having issues with water contamination. Think Flint, Michigan. So this would just add an additional stressor on the already stressed water system. And I'm only really talking about humans. If we can also imagine what that'll do to the natural environment, because we also have a drought in general. A lot of our forests are dying because they're too dry and they don't have enough water to access. And we also have a lot of areas that are what it's called desertifying, where they're becoming so dry that they're basically converting from forest into just dry scrubland, where instead of having trees, you just have like short, scraggly bushes and stuff like that. And that contributes to that. It's a feedback loop where the more things turn to desert, the less water the ground is able to hold. Soil can hold far more water than sand and dirt. So the regions around the perimeter of the forest are more likely to turn to desert. So again, this is just going to be another stressor on our water system. It's estimated that by 2050, most of the water withdrawals for concrete production will be in geographical regions that already face water stress. I'm actually going to be right back. I have to do something for my kid. My bad. I'll be right back. My bad. Speaking of water stressor, my kid was stressing out over wanting a cup of water. So, yeah, concrete will inevitably cause issues with the water system as well. And kind of like what I was saying with the heat island effect, where water will, or where the concrete will increase the temperature of the ground. As you extract more water from the ground, it also makes the ground hotter. That's why deserts are so insufferable if you ever walk around in the summer heat, because there isn't enough water in the ground to mitigate the heat, because water holds heat much better than rock. So when you have water in the ground is able to stay cooler because it slows down the heat release into the environment. Whereas rock, it goes into the ground and comes straight back out as additional heat. So if you have a whole cluster of tiny homes, it might get really hot if you don't do other things to mitigate the temperatures coming off of those homes and inside those homes, especially because if you do like a 3D printed thing and there isn't very many windows or doesn't have adequate ventilation, it can get very toasty inside. So it really would depend on how they're being built and how responsive the companies are to the regional climate needs. And I can definitely imagine that it could get hot in some of those homes. Granted, really, really thick stone buildings are good at cooling things down inside. The missions in California are made of incredibly thick stone material, and they stay remarkably cool inside. And when I say thick, like some of the walls are a good like foot thick. However, it does have a mixture of vegetation inside. Adobe is made from clay, I believe, and then a mixture of grasses. So it's more of like an organic material. I honestly don't know if the plants help mitigate the heat because they do have more water components in them. But I would, just my own educated guess, I feel like the vegetation inside would have an impact on that. It also helps with the structure of the material because it adds a fibrous matrix inside that helps the stones hold together, or at least the material hold together. It's not actual stones, they're like solid. So yeah, concrete is incredibly intensive on the environment, and that's not even factoring in all of the stuff that is required to extract it from the environment. You have to remove the rock with heavy machinery. Oftentimes you're damaging ecosystems as you're doing so. And it in turn can result in biodiversity loss because animals are losing their habitat, trees are losing their areas of distribution, and when you kill off those habitats, it makes it harder for populations to exist. There's something called fragmentation, where if you go in and you split a forest into pieces, the pieces of the forest are more likely to fall apart. The populations of animals are more likely to struggle because they don't have a cohesive living situation. So yeah, there's a lot of issues with concrete itself, and that doesn't even cover the structure of the building. Also, fun fact, concrete paving can increase urban temperatures by up to 7 degrees Fahrenheit. So if you have a 80-degree day, you potentially could have up to almost 90-degree ground temperature because of the material that you're using. So yeah, it possibly could make the inside of your home significantly hotter than the outside temperature. So the material itself is a problem that needs to be considered with the production of these buildings, especially if you're going to there's hopes from all of these companies trying to use 3D printing to kind of replace the modern methods of, or the tried and true methods of building homes. But, you know, if if you have all of these other issues, it could make it so it's not really a feasible option. And it could be potentially more dangerous to the people living in them than it would ordinarily be. Another benefit, which to me I think is kind of negligible, but lower fire risk, because obviously concrete is not flammable, but it's still potentially not safe for your health. You could, as your house starts to degrade, the dust coming off of your home could be introduced into the air. You could end up breathing in parts of your home as it is crumbling. It's also harder to me, this is the biggest problem. I mean, the environmental part, but when you print these homes, they're not going to be like wood framed houses where you have the wood pieces and then you have spaces in between where you can put the plumbing, the electrical stuff, all of the components that make up the industry of the house, the functional parts of the house. It's not going to be as easy to add ventilation. And so if you have any issues with your house, plumbing issues, pipe breaks, electrical whatevers need to be fixed, I genuinely wonder how that can be fixed without having to tear down the whole house. Because if they embed it into the concrete, you're going to have to basically break down the wall to fix it. When they do work on homes, they'll usually cut out a small section to fix what they need to. If anything, they'll maybe break down one wall or pull up the floor or do whatever they have to do, but they don't have to break down your entire house just to fix a minor issue. And I don't know how exactly they plan to incorporate these types of things into the structure of the concrete without making it inaccessible. Because if you embed it into the concrete, when it is time to fix stuff, you're going to have to break through the concrete, and it's not all that easy to just cut through the concrete cleanly. Like, there's going to be crumbling, and replacing it is going to be difficult, I imagine. Also, like, when you cure concrete, you have to let it sit flat because it's wet and liquidy. I don't know how you'd fix a hole in the wall if, like, I don't know, maybe make a frame or something, but I see that as a really big problem where you might have to take down the entire house just to fix one component inside. Granted, maybe they have methods that I'm not thinking about, or maybe I just don't know enough about construction to understand how they'd fix something like that. But to me, I see that as a big problem. And then, as I said way at the beginning, these houses that have been built already have already started to show signs of decay. They're already cracking. Some of them are crumbling, like having issues with crumbling. And so that itself could introduce toxic damage to people living inside, especially if it's poorly ventilated. You're basically going to be in this small, tiny thing, concrete home, and then you're going to be breathing in all of this dust, which sometimes concrete, depending on the materials used, can actually emit radioactive substances as well. Potassium can be released, which is highly reactive to the atmosphere. Uranium, radon, and thorium are all different malleable metals that can be found inside concrete. And so, as we all probably would have guessed, you don't want to be breathing in radioactive material on a regular basis. I mean, honestly, you don't want to be inhaling it at all. So I can't imagine how stressful and dangerous that would be to live in a home that emits an actual radioactive material, or even a collection of radioactive materials. In the basically before actual like central heating and electrical heating, stuff like that, when people primarily heated their homes by burning coal or wood, a lot of the life expectancy issues, or not a lot of them, but a portion of the health declines were because of all of the ash and materials that were being released into the air. If you ever have seen an old house, like I'm talking 1900s or before, you'll see, particularly stone houses, you'll see like blackened ceilings. Same with caves that had been used by cave people. They'll have blackened ceilings because all that smoke just went up and contaminated the ceiling, integrated into the ceiling. So that breathing that in caused a lot of issues for people in those ages, and living in concrete homes could have a similar effect. So yeah. Additionally, when you heat up concrete, it releases carbon dioxide into the atmosphere. And so if you're in a home with increased carbon dioxide, it can also cause ill effects. A lot of people don't know this, but high concentrations of carbon dioxide can actually impact your health, your mental acuity, and it can actually lead to like mental decline if you're exposed to high enough levels. It can it can make cognitive tasks more difficult. It can make you more sluggish, more sleepy, impair your ability to reason, and the symptoms get more severe as you have higher concentrations of CO2. Additionally, if you have a smaller home that is not adequately ventilated, you breathing out is also going to contribute to those CO2 emissions. Not to mention, if you have appliances and other things in your house that are emitting CO2, it could potentially cause issues as you inhale higher quantities of carbon dioxide. So a lot of issues in general with just the material. But there's also issues with making this a viable option for keeping up with the housing shortage. Not only concrete is in relatively short supply, in the sense that it's a non-renewable resource. Once you use up the type of stone that is required to make concrete, You can't just grow more. You can't. Maybe we'll get to that point in the future where we're able to manufacture rocks. But as of right now, like limestone takes millions of years to produce. Um, a lot of the other stones that they sometimes incorporate take a very long time to produce. It's also like the most accessible sources of limestone have been heavily utilized already. And so it would take more money, more effort to go into the regions that have not been used and taken advantage of. So there could be a supply shortage of the materials needed to make the concrete, especially if you're trying to do this on the large scale at the same time that we're also developing in areas other than this too. Obviously, cities are expanding. There's more need for modern spaces, modern human spaces than ever before. So there could be issues with the material access in the future. There's also a shortage of what do you call it? Expertise in this. You can't just have you have to have engineers that work on this, and there's already kind of a brain drain, a shortage of people that have those types of skills. And by not having enough people to like create these models and supervise the production of the models and know how to use these 3D printers, it can lead to kind of a bottleneck in the accessibility of the people who are able to create these. There was a huge project that was attempted to be undertaken in southeastern Illinois. They had they put in about almost $600,000 into creating a small town of 3D, basically a 3D printed duplex. But it basically got abandoned. They promised that they were going to create like an affordable housing increase and produce homes enough for all of these people that were really struggling to find housing. But they have not finished. They basically they didn't even finish the duplex. As I said earlier, with this particular structure, they already had cracks running through the walls, and by a year later, they really hadn't had any. That nobody had moved in, and it basically has just been sitting on a lot, not doing anything. They also were having issues with the investment type of issues, and there's a theory that this was basically a publicity stunt instead of an actual concerted effort to help with homes. So there is a potential issue with, you have the people that are willing to do this stuff and are willing to and have the skills to work these machines, but they don't have our interest at heart, and they're basically just utilizing these machines to take advantage of people, which I would not be surprised, especially with how things are lately with billionaires and whatnot. So yeah, there's an issue with labor and the actual production of these types of these types of communities. So there's it can very much depend the quality of these homes, the efficiency of the production, the ability to actually meet the demands of this housing issue is heavily dependent on the companies that are actually doing the work. And with how rich companies are and cutting corners, there is a significant risk, in my opinion, of people doing it as cheaply as possible for maximum profit and basically taking advantage of people who have hopes for those projects and invest in these projects. So yeah, there's quite a lot of issues that could potentially come up with using 3D printed homes. Not only are the materials an issue, the labor availability is potentially an issue. The ability to maintain these buildings can be a potential issue. I've seen a lot of hybrid versions where it's not just all concrete. They have like wood and metal roofs or and like glass windows and stuff. So they do look like modern homes, but I do genuinely wonder about the feasibility given the appliances and whatnot that would also need maintenance. And I would also have concerns for the type of air quality that you would find in those types of buildings. And again, as I mentioned, it would also heavily depend on where you put these homes. If you live in a seismically active region or a significantly hot or humid location, I imagine there could be issues with the suitability of these homes in the long run. This is definitely something that I wouldn't say we should give up on, because there are still advantages. And honestly, with the way the housing crisis is going, with the number of people that I'm seeing moving into cars, moving into storage units, living in the wilderness in a tent, I wish I was exaggerating, but we have a huge unnoticed homeless problem in this country right now. There's a lot more people than we really recognize yet that are living off a property, or even people that are like having to live with a whole family. Like you have additional people living in the house, just because some of those people weren't able to afford their home, so they had to move in with relatives or friends or other situations. So I don't think we should give up on the idea, because it has a lot of pros. The speed of production and the lack of materials or reduced material needs. But I think we definitely need to do a lot more testing to understand how these stand up to different environmental disasters, earthquakes and storms, how it holds up to heat, how it holds up to freezing temperatures, and how to kind of meet the regulations that are required for most cities. Because there definitely could be a lot of issues where cities won't allow these homes to be built because they go against building codes. So there's also a lot of like legal stuff that needs to go on behind the scenes to make this a more feasible business to rely on. So I have hope that as this type of stuff gets developed, we can come up with solutions that reduce the negatives. That there are ways around some of these things, like putting up certain wall coverings and whatnot that can reduce the amount of dust that comes out. Finding a way to which I think it's not Roman concrete, but there's a certain type of concrete they just now discovered how it was made. But it's a particular type of concrete used in the Mediterranean region during the Roman era that was found to be significantly more durable than any concrete that existed. And they just recently found out that it was because it had, I think it was silica in it. I forgot exactly which material it was, but basically the premise was as it aged, it actually, the harder stone inside it's like kind of spiky at a molecular level. It, as it water intruded, it would like allow that harder material to kind of like grow inside the concrete, which made it even more stable over time. So maybe we can find other methods to make concrete more resilient and less likely to crack, less likely to hold in heat. But again, this is something that is going to need a lot more investigation, a lot more engineering, understanding, and I wouldn't say that it's an immediate solution right now. I think we should still be very cautious in putting all of our eggs in one basket, and should still investigate other types of construction methods that reduce our impact on the environment, produce enough homes for the people that need them, and reduce the risk for the people living in those homes. So I hope you found this topic to be interesting. I have always been fascinated with housing just because of I don't know, it's kind of like an invisible crisis. People don't like to talk about it and admit that people are struggling out there. This has been an issue that we've had for a while, but I think it's been brushed under the rug. So I think it's a very cool topic to look into. And again, I think it should be considered a solution, but we need to do a lot more work to make sure that it's actually a viable solution that reduces the risk rather than just be another method of terrible housing that exists out there. And I mean, as we know, with the way construction has been going with normal houses, they're totally cool with putting out houses that are not good. So we just need to make sure that the solutions we have for mass-produced housing are actually beneficial, and that we're not just going to create hundreds of homes that are actually unlivable. So yeah, I hope you learned something from this discussion. And I look forward to seeing you guys Friday, next Wednesday, whenever you join us again. And yeah.
His own attitude towards the possibilities of peace, towards the Soviet Union, towards the force of the Cold War.
So it was a way of making me feel that they were a part of it.
You see it on the screen. If the government had to change the school in the grid, they have to shut it down. We got state troopers out there. They got planes flown. They have those strange machines.